Now working through some Lenz's law questions, we're going to consider a conductor PQ of length 0.10 meters and resistance of 0.20 ohms, being pushed to the right at 1 meter per second. If the rail is placed in a magnetic field of 2 Tesla, perpendicular to the rails and connected to an external circuit of a resistance 1 ohm, what is the magnitude of the EMF produced? Well, from this we can use our equation that our EMF is equal to the magnetic field times a length times a velocity, which just gives us that 2 times 0.1 times 1.0 is going to give us 0.2 volts. What is the current and the potential difference across the 1 ohm load? So not the conductor itself, but the external load. So from Ohm's law, our EMF is going to be equal to our current multiplied by the total resistance of the circuit, which gives us, as all components are in series, then the EMF or voltage is going to be the same throughout the circuit. What is the direction of the current? Using the right-hand rule, our fingers follow the field, which are pointing into the page. Our palm is following the movement, so it is facing to the right. At this moment, our thumb, which is normally our current, is pointing down. However, we now know that Lenz's law, the current will oppose the change in movement, so therefore the current will actually go up the page from Q to P. Our next question, a loop of wire of radius 0.3 of a meter in a magnetic field of 0.8 Tesla. If the loop was initially perpendicular to the magnetic field, was rotated 90 degrees in 1.2 seconds, what is the magnitude of the induced EMF? Well, the EMF produced by Faraday's law is the change in magnetic flux over a change in time. In this situation, we have a constant magnetic field, but a changing area. In this situation, we have a circle of radius 0.3 as it initially starts. However, as it is rotated 90 degrees around an axis, the area that is actually going to be in contact with the magnetic field is going to be 0. So, now we can just plug all the remaining numbers in, which gives us so the magnitude of the induced EMF is 0.19 volts.